Hello everyone. So in the previous video, we have stopped till the explanation of EA bar. What is exactly an EA bar? Okay, I will try to explain you in this video also. Let's jump up to the directly to the topic with wasting any sort of time. Okay. So see here, this is an EA bar. This is an proper explanation of EA bar. After viewing the slide or photo on the presentation, you can clearly see that what is the work. Okay, then also I will explain you. Yeah, that's why I am creating the video. Yeah. Okay, so explaining for the explanation of EA bar, what does it does? Okay, slowly tries to confront that what does the bar means. Bar means in technology or in a technical language, bar means a complement of something. So what is EA means? EA means external enable access. Okay, so try to hear that. That is very important. When EA bar equals to zero, what does it is actually mean? It means EA equals to 1. Yeah. When EA bar equals to 0, it means EA equals to 1 because EA bar is a complement of E. Yeah. It is a complement of E. When EA bar equals to 0, EA equals to 1. What does mean? External enable access is equal to 1. And what does 1 means? True. True means on. When external enable access is on, at that time we have all the authority with us to use external ROM first instead of internal ROM. Yeah, that's the simplest way I can understand, I can explain. Okay, so you can see that you can clearly set up in your mind that when EA bar equals to 1, just learn that when EA bar equals to 1, at that time we only uses internal ROM. Okay, because we don't have authority or we don't have permission from the processor that we can use external ROM. We cannot decide it by our own. Okay, after all, processor is the topmost prior authority at that controller. Okay, so EA bar equals to 1. What does that mean? EA equals to 0 means external access is 0, false. That means it is off. What does that mean? It means we cannot use external ROM. Okay, as we cannot use external ROM, we have to depend upon only internal ROM. So internal ROM is of 4 KB. 4 KB starting from which address? 000 to FFFH. Okay. Why does this FFF only 3F has been come? Because for the 4 KB, you will have 2 raised to power 12 location, and 2 raised to power 12 is nothing but it can be represented by 0 FFF. Okay, that you might be learn in second semester also. I cannot explain it to you right now in each and every video all the things. Okay. Here some of the students get confused. Sir, here it is EA bar equals to 1, then also we are using external ROM. So see, at some point we are self-sufficient with internal ROM. Okay, but we we are not confirm that in the future we need or we don't need. Okay, at that time the address has been divided. Okay, so whenever the processor has EA bar equals to 1, okay, it is clear that to him that I have to use internal ROM only. Okay, but suddenly some programmer gives him the address that is something address location of 100H. Okay, so he have cleared in his mind that address 1000H is can be only be present in external ROM. Okay, it cannot be present in internal ROM. So that's the clear message to him that it must be in external ROM, because internal ROM has not that sufficient amount of address locations. Okay, it only has 000 to 0FFH, that is 4 KB of memory. So remaining 60 KB of memory it can be accessed from the external ROM. It is a There is a catchy point for the Viva question. At each time we can only access up to 64 KB of memory. Okay, it can be both, or it can be one, or it can be 4 KB. Okay, maximum at a time we can only access up to 64 KB of memory. That's the catchy point of this whole topic. Okay, I will cover the theoretical concepts. Okay, wait a minute, I will cover it. Yeah, here we can clearly see that S051 has a 4 KB of internal ROM. I have already told you. Okay, you can clearly read all addresses from 000H to 0FFFH. It is due to 2 raised to power 12. 2 raised to power 12 is something for 4096 locations, or the bits. Yeah, 4096 bits. Okay, sorry for the location. Sorry for the location. Okay, any addresses beyond that will be invalid. Obvious. If EA bar you are stating that EA bar equals to 1, and after that you are giving the addresses above 4 KB, that above 0 FFFH, until and unless external ROM is attached to it, until and unless if in this situation that it means that external ROM is not attached, so you are giving the address that is out of the range of internal ROM, then of course processor will get headache. Yeah, processor will get headache, and it is not invalid. Okay, where the program will be suddenly stop and you will be get to your manager, sir, what's happening, and the manager will give you the file later. Okay, that's not going to happen. Okay, in such systems, EA bar equals to 1 as internal ROM is being used. Okay, okay, I have already told you EA bar. Here also, when the internal external ROM is used, at that time also EA bar equals to 1. Mainly, mostly the students get confused when they have asked that will external ROM will be used when EA bar equals to 1. They said clearly no. Yeah. In some teachers does not explain that. Teachers just say that even EA bar equals to 1, only internal ROM will be used, and when the EA bar equals to 0, only external ROM will be used. Okay. Student, that does not fault of the student, but the teacher does not explain it clearly. Okay, I have already told you. uh, Here are, you can read it here. Okay, some important topic I get to see, I will explain you here. Okay, only external ROM. Okay, yeah, it is clearly stated that the program stored in the internal ROM may have become invalid or outdated, or the system may need to be upgraded, etc. That's why we use external ROM. Okay, this is a reason. This is not always a reason. Sometimes it's our own our own urge to use this external ROM, because we do not go in simple way. Okay, so let's continue. Use of EA bar P in 8051. I have already told you. Then the internal EA bar equals to 0. The internal ROM is completely discarded. Yeah, that's also a word. It is a technical word that when EA bar equals to 0, the internal ROM is completely discarded. It is not such that we will use first external ROM and then we can use internal ROM. No, it cannot be. As we can at a time we can only use 64 KB of memory, and external ROM is self-sufficient with its memory size because it is up to 64 KB. Okay, 8051 checks EA bar pin during every ROM operation where the address when the address, yeah. Look, if I have given some sort of address, if I am living in some sort of Mumbai city, okay, I have given some radius of address, 500 meter from your location, have a radius as a circle area. Okay, I have given address in radius because in that radius of area, something is happening. Okay, something is happening. But if I will but if it is there that if it is such that the same radius will be having in parallel universe, suppose the parallel universe, then I will get confused that which universe your radius, the radius you are talking about. Okay, so I need to specify that. Okay, so here EA bar equals to 0 does the same. When EA bar equals to 1, I specifies that it is of my internal my universe. Okay, I'm talking about my universe, so I will take the information from internal ROM. If EA bar equals to 0, I'm talking about another universe. Okay, that's the simple explanation. Okay. So let's come upon what is the internal RAM of 8051. Internal RAM of 8051 is of 128 bytes, not of KB, not of MB, not of GB. It is a 128 bytes. That's a question to many of the students that what we can do in 128 bytes. Obviously, you must have the question because the image I am showing is obviously up to 500 KB. I don't know the perfect size, but what can we do in 128 bytes? Okay, we can do a lot in micro in quantum science. Okay, when we use study now, when you study microchips or VLSI, all the concept that Intel does. Okay, that your motherboard has been designed up to, you will get such a beautiful vision of the human mind. Okay, you cannot also expect that how they created, how they imagined that, how the marvelous technology has been introduced in today's world. You cannot imagine that. Okay, so let's come to the jump of the topic. Structure of internal RAM of 8051. Okay, it is of 128 bytes. It is divided into three sections: 32 bytes, 16 bytes, and 80 bytes. 80 bytes is of general purpose RAM because programmer can be used for anything. The programmer can use that space for anything, for storing any information or anything. That's the part of programmer. Come to the 16 bytes. This area is a bit addressable area. Okay, I will explain you what is a bit addressable. If one byte consists of 8 bits. Okay, so this 20H location, 20H, you can see that this 20H location consists of 8 bits. Okay, so these all 8 bits are bit addressable. So what does that mean? Bit addressable means each bit can be addressed or accessed individually without affecting other bits. Okay, that's called a bit addressable. If I do some certain thing that set a bit 00 as 1, the set a bit, it actually means 1. Okay, set a bit 00H. Okay, I have write that code. What does that mean? It means 00 location 00, the beat location 00. Yeah, I come across the beat word because it is a very much necessary, because 00 location also has the byte. Okay, byte address also has a 00. Beat address has also has a 00. So how does the processor will differentiate between both the programs? Yeah, the programs syntax. Because in generally in bit addresses or the bit programs, I explain you bit. I'm telling you bit programs. Okay, we only use set a bit and clear a bit, complement a bit, and some logical operations that only for boolean or bit programs. Okay, but while writing the byte operations, we use add, move, like that. The syntax or the all the other syntax are different for bit and byte operations. That's why the processor did not get confused. Okay, neither do. Okay, so that's a clear explanation. So here, if I set a bit 00h as that's indicate that we are setting a bit 00, means we are sending one or enabling one at 00 location. So it will be one without affecting other 7 bits. Okay, this other 7 bits, it does not affect that. That's called bit addressable. Okay, and it is this is not an bit addressable. It is not bit addressable because once I did 30h as one, it will I cannot change minute locations. So suppose if the 20h is not bit addressable, suppose that if I send moves 20 move 01 or move 20h comma 0 hashtag 01, what does that mean? The value that stored at 20h location is 01. So after the calculation there is some form of binary formation here, that is 842 and 842. I will tell you when we will start about programming. Okay, at that time I will explain you thoroughly. Here you can see that if I suppose if I have 01, that it is all four last 4 bit will be 0, and here this 3 will be 0 and this will be 1. I cannot change it. I cannot change it. I cannot take this as 1 and this as 0. It means 0, 1, 0, 1. I cannot do that. Okay, uh, that's a simple explanation. So let's come to the last part, that is the 32 bytes. Why does that it has been divided into bank 0, bank 1, bank 2, bank 3? This is due to the number of opcodes. When the opcode increases, the processor has to be more efficient because opcodes requires and space, and processor's memory has not such amount of use space. You can clearly see that if I write the codes of 32 bytes or all the registers that starting from R0 to R32 or R31, it requires a huge space because each instruction has been converted to opcode. Opcodes has its own space. Okay, that's I will explain you the architecture of computer. Okay, there is such for now when Viva or any external asks you that why the banks are divided into four. 32 bytes are divided into four banks. Just tell them that due to the numerous number of generation of opcodes, we have divided the banks into the four parts. Okay, so bank 0, bank 1, bank 2, bank 3. Each bank consists of 7 registers. We can at a time only one bank can be active. Okay, the activation of bank can be done by PSW registers. No, not the PSW registers, but same type of register that will be explained. I will explain when I start with timer theory. Okay, not now. Each bank can be accessed at a time, and it can be enabled using some SFR. Some SFR. Okay, I will not tell you the name of SFR. What does SFR means? SFR means special functions registers. Okay, let's move. Yeah, it is clearly mentioned here. You can read that 805 has 128 bytes of internal RAM, 128 locations of 1 byte each. Uh, the RAM is used for storing the data. Okay, the first part I have already told you about. The last part here it is first part here, the register bank. The first 32 location of the internal ROM from 00h to 1FH are the general purpose register. Having so many general purpose register making programming easier, but as a downside, this also vastly increases the number of opcodes. Okay, hence the 32 registers are divided into four banks, each having 8 registers. Okay, so that's I have already told you all the points I explained in the previous slides only. Okay, yeah. Here it is given the appropriate bank can be selected by the RS1, RS0 bits of PSW register. I have covered the PSW registers, program status word or program status whatever you can call in your syllabus as it is given. Since PSW is available to the programmer, any bank can be selected at a time. Okay, RS1 and RS0 help for that. Bank 0 is selected by default on reset. When you reset the phone, automatically first the first system selected using the BIOS setup. BIOS setup has been already a default setup that has been designed by the manufacturer. Okay, that's I will tell you or explain you in the COA. Okay, computer architecture. Bit addressable area. I have already told you already. So you can read or take screenshot. Wait a minute. You can take screenshot of it for your reference. You can read it when you are free or after the lecture. Okay. I hope you have taken the screenshot. So now come up for stack of 8051. Stack is the most important topic. Stack, what does the stack register does? Stack register is a SFR, special function registers. Yeah, it is also an 8-bit register. It stores the location address. It generally has the location address of internal RAM only. So there the question arises, why does the address is only of internal RAM? Why cannot it can be in internal external RAM or in internal ROM or in an external ROM? It cannot be because the address we can store it up to 8-bit only, and the external RAM and internal ROM and external ROM can have the address of 16 bits. Okay, but we cannot store the 16-bit address in 8-bit registers. Of course, we cannot. Okay, okay. So that's the reason. That's why stack is present only in internal RAM. That's a point where the external catches you. Okay, that's the important point. Okay, let's move forward. So where the stack exactly present in internal RAM? Okay, it's present at the location from 07. Yeah, 07. That is of bank 0 last location. So here is a catch, but we do not have any use of 07 location. We do not want to disturb the default bank. Okay, we do not want to occupy the space in bank 0. Okay, because that's a very major bank that we needed as a programmer. Okay, when you started finally embedded programming, you will notice that what is the main or what is the importance of bank 0. Okay, so we do not want to just excel or just have an empty use of bank 0. Okay, this does not affect. Yeah, it is clearly written the reset value of sp07h, because on the first the push I will explain you. Yeah, read it from here. This means the very first data will be stored at location 08h. This does not affect the default bank 0 and still gives the stack the maximum space to grow. Okay, we do not disturbing bank 0 and uh, we still are using maximum space available in internal RAM. So what does means push and pop means? The push means first pushing of address to the another location, upward location, and then inserting the data. That it means push. Okay, what does that mean? Pushing. First pushing you from the large building and then declaring you as a dead. Okay, that's the operation of push. It will first push the stack pointer to the new location. The stack pointer now containing the address of new location, and then I am pushing the whatever the value I have to store at that location. Okay, that's the simple push means. What does man pop means? Pop means first fetching whatever the value stored in the location. First getting that value fetch. Suppose in previous example, as I have declared you dead, but you are not dead actually. So I will do, I will first fetch out the information or the news that I have spread across that you have been dead. So I will fetch that information first. Then uh, I will pop you. Means then I will pop you means I will take you to the hospital. Okay, that's the simplest example I can give. Okay. That's you can read here. Another important element of internal RAM is the stack. Stack is a set of memory location operating in the last in first out manner. LIFO. Whenever the messages comes, text messages comes in your mobile, it operates in last in first out manner. The recent messages will be on the topmost in the notification. Yeah, when you slide or you have read that notification, you will just slide out. That means the last first notification that has been come. Okay, last in first out. Okay, the last notification that has been come to your notifications screen, it will be out first. Okay, because you will read the recent messages first. Whenever in your WhatsApp also, it also works on LIFO. The recent messages, that is the last in messages, comes to the top of your feed, and you out them first only. Okay, then you must read out them first only until unless some girlfriend message has been come in down list. Okay, nowadays people pin the important persons. Okay, also. Okay, so that's not a point of discussion. It is used to store written addresses during ISR interrupts. I will explain you when I will start with interrupts. In 8051, the stack can only present in internal RAM. I have already told you, because SP, which is an 8-bit register, can only contain 8-bit addresses. Okay, that is only 8-bit addresses is a part of only internal RAM. Okay, so here we can conclude with the topic today's. Please write something in comment section. Nice, good, bad, worst, and improve. Yeah, please write it. Don't only watch the video. This is a request to everyone. Okay, so I will stop right now. I will continue with addressing modes in another video, in next video. Okay, thank you everyone for stay tuning and hearing me. And okay, thank you.